Hello everyone, my name is Jimmy. I'm a technical support engineer in DAN. In this tutorial, I will introduce you how to set up the geometry of this model and also assigning the connections between the excavated soil and the outer soil, and also the interface between the soil and segments, and also the interface between the segments inside each rings and also between different rings. After that, I will introduce the setting of the boundary condition, including the boundary condition at outer soil and also the boundary condition that imposed by the supporting TBM. And then I will introduce you the setting of the material properties. And after everything is set up, I will explain about the meshing method, and then I will discuss the geomechanical stage construction analysis in Diana and the setting according to the excavation and installation of the segmented tunnel. And in the end, I will introduce you the result of this simulation. So first, we need to create a project. So we name this project tunnel, and we choose only the structure, and we set up the dimension of 100 meter using this meshing setting. And after the project is created, we will first define the unit. So here we keep the rest of the unit intact, and we only change the angle to degree. And in Diana, we follow the workflow of creating geometry, mesh, and analysis. And here first we create a sheet to generate outer soil. So set up the coordinate of this sheet, and according to this geometry, we can further create a outer soil. And now we click create. Once we have the sheet ready, what we can do next is to create the size of the tunnel. So here we name this slice 1 excavation soil because the tunnel is installed based on the size of the excavated soil. So we create a circular sheet with the size of radius 2 meter, and we create. The next thing to do is to subtract the outer soil with the excavation soil so that we have the two entities ready. So we need to keep the tools here, and now we have the two outer soil and also excavated soil. And then we use the function extrude. By extruding the excavation soil 1 in the offset of 1 meter, we get the first excavation soil, and then we do the same with the outer soil, but instead we choose it to 6 meter because we're gonna have 6 rings in this model. Next, we will create a segmented tunnel. First, we hide the outer soil, and then we select the face of the excavated soil, and we right click, we use extract. Then we have the face surrounding this excavation soil, and we will use it as our segmented tunnel for the ring one. So we name it slice 1 segmented A, and we keep this name to name later because it will be easier management. And then because it is a segmented ring, we need to cut the whole ring into different pieces. So first thing to do is create a polygon sheet. So here we create a horizontal sheet that can cut the plane into 2 halves, and then we use the array copy function to cut the rest of the ring into 6 pieces for each ring. And we can use the array copy function with angles to do this easily. And then we use subtract to subtract the ring with the sheet we just created. This time we don't need to keep the tools because we do not need to cut plane later. So now we have the 6 pieces of segments ready for the first ring. And then we will do the array copy for the excavated soils to make it the going through the whole the excavated tunnel. we do the same with all the segments using the array copy function, but here we need to apply a rotation degree because we want the segment internal to installed with the joints intersect with the each other. We renamed it here so that when we do the array copy function, the changing of the name will be only occurred in the slice number, so we can better arrange it in the future. So now we have all the segmented ring ready. We need to arrange it into different group so that we can activate it and or deactivate it the geometry easily with the phase analysis and also the stage construction analysis. So now we have the whole set ready, but some entities are hidden inside. We cannot choose them easily. So what we can do is we use the virtual transformation function. We first activated the virtual transformation visible in our graphical interface. Then the next thing to do is to move our excavation soil in -y direction with the center of 48, which is the plus x face of the model, and we move it out, and then we move the outer soil in the other direction so that we can show the segmented tunnel. And we also do the same with the segments, but we use the explode function so that we can better select the interface of the segments. Next thing we need to do is assign the connections. So before assign the interface elements, we need to unite the outer soil and inner soil, because once we assign the interface, they will be separated. So here we choose the outer soil, and the inner soil we choose the unite, and auto we unite them. And next thing to do is to assign soil to segment interface. Here we choose the interface connection type, and then we select the inside as the source and all the segments as target faces, and we choose the element class and also the material. Here we named it the soil to segment interface, and we use the material model linear elastic, and we fill in the material properties here. And we also need to define the geometry of this interface because we want to align the local element axis based on the cylindrical shape of this tunnel. So we fill in this information about the tunnel and close it, and you create. So that you can see here the red part represent the source faces, and the blue part represent the target faces. And next thing to do is to assign connections between different faces. So here the first thing is to assign the interface between all the wings. We name it interface between segment actual direction, and we use the convention of from left to right. So here we select the edge of the left side as source, and then we will select the edge on the right side as target. You can do this by easily arranging a visual angle so that you can select it easier. And we also need to create a material for it. So in this case we name it line interface, and we will use the material model called Janssen model, which can simulate the bending of the joints. So here again we fill in the material properties, and we use the default for the Janssen model, And then we also need to create a new geometry based on the thickness and also the shape of the tunnel. We named it the line interface, and we will need to fill in the thickness of the tunnel, 0.2 meter, and also we need to set the shape to align the local element axis, which is the same with the last one we did. And then we create. So now we can also see the red and the blue part based on the source and receive, the raw source and target that we just assigned. And next thing to do is to assign the interface between the segments inside one ring or different rings. So we call it the interface between segment, but in circumferential direction. And here we use the convention, a clockwise convention, so that we can select the edge from the one side of the segments and then the target in the other side. And we choose that easily by selecting the view angle from the front and back. This is very convenient to select all of this. So in this case, we will keep using the same material model, the Youngson model for the interface element, and also the same geometry for this interface as well. And once we create, then we can see the connections that is already established in the segments and also the soil. And then the next thing to do is to assign the boundary condition. So there are two type of boundary condition. The first type is the boundary condition. This is activated throughout the simulation, so we call it BC, and we will assign the boundary condition in the outer face of the outer soil to prevent normal displacement across the sidewall and also the bottom. And we choose Y in the other two direction, and we limit the translation in the Y direction. We call it, and then we name it BCZ to support at the bottom. And the next set is BC excavation, which is representing the support of the TBM machine. So we will need to create a different set with different support to simulate the support of the TPM machine on one end of the tunnel. So we have to select one side of the excavation soil each time to simulate the supporting of the TPM machine once with different phases. For example, to simulate the progressing of your excavation and installation. And we will need to do it for the rest of the phases as well. So now we have the boundary condition ready, we will need to assign material properties for our model. So first thing to do is to assign the material property for the soil. So we will assign the outer soil and the excavation soil with a soil class using the default material model, and we need to select the initial stress to initiate the stress in the soil, and we fill in the material property here, and also the material properties for the plasticity. And then we need to fill in the K naught to initiate the stress in the soil, and then we apply, and then we need to assign the the material model for the segmented tunnel. So we use regular curve shell to simulate the segment, and we call it concrete, and we use the concrete and masonry class, and here we use the elastic model. And there are many other choices. If you have other needs, you can also choose the different material model as well. So we also need to set up the geometry of our model. So it will be the same as the line interface, the connection interface that we just make. We will use 0.2 meter as thickness, and we will need to set up this to align the local element axis. Apply. So now we have the material model ready, and next will be the meshing. So we select, in this case, we choose a very simple meshing strategy is to set all the elements with 0.5 meter, and we click generate mesh, and now we can see the mesh in the mesh type. And then we move on to analysis. And in analysis, first we need to create a analysis. We name it internal, and we will use the stage construction analysis. So in stage construction analysis, the gravity is automatically applied. So here we adjust the iteration method into second, so that the iteration is faster. And we first at our first stage, which is the initial stage, where we call it the initial. And here we need to set up the no water present, because we do not simulate the groundwater flow and also the hydrostatic pressure. And we change the number of increments into 4. And because we don't have any ring activated we don't have any ring installed, so we have to deactivate the ring, and also deactivated all the boundary support of the TPM machine. And we can simply duplicate it to create the next phase, so that we don't have to deactivate it again. So here, but we want to clear displacement due to the stress inertialization, and we will also want to activate the ring one, and also deactivate the first soil, and also activate the support of the TPM machine. And we do the same with all the other rings, but here we don't want to clear the displacement anymore. And here again we activated another ring and deactivated another soil, and then activated the next support of TPM machine. So forth, and in the end we will have 7 phases, because the initial phases as well. And once the whole stages are set, we can use this phase dialog to check our setting. So in this case, it's very regular setting for each phases. Then you can see that they are very beautifully aligned inside the dialog. So in this way, you can make sure that nothing goes wrong with your setting. And you can also change the material for different phases. In this case, we will just keep them identical each phase. And now that the analysis is successfully set, we move on to the result. And in the result, here we will first check the initial stress with the gravity. So here we can see that the initial stress is set based on the soil gravity. And in order to see the stress inside the ring, we can hide it in the mesh terminal, and then we can move on to the next phase, and we can see the stress start to occur. And you can also check the distributed moment to see the bending, and with different phases you can see the bending is increasing. And you can also check the distributed force, which is the bending forces on the phases, and the changing with different stage and phases. And because we use the Youngson model, we can also see the interface bending, which is the bending of the joint. So we use line diagram, then you can see that the bending of the joints mostly happening in the longitudinal joint at the wall. And we can also see the distributed forces, with the interface distributed forces at the joint. And yeah, this is all the result that we presented for this tunnel. If you're interested, you can try this tutorial online. So you can find this tutorial in the Diana tutorial, and you can also find other models, very intuitive tutorial here by applying the filters based on your needs. And you can also see the user manual to further develop your modeling skills and also make use of different models. Thank you so much.